Okay, everyone, let's take a look at how to get to these measures without having to go through these horrific calculations. I mean, hopefully you realize, imagine if our data set had more than 5 values in it. It would be ludicrous to think that we should create a table like I did on the board for the average deviation or for the standard deviation. So I've built you this thing called the Excel calculator, which I'll click on right now and open. And this thing has a lot of sheets and a lot of parts, and we're going to learn them as we go through the course. So I'm just going to crack it open now. This thing has a lot of sheets, a lot of moving parts, a lot of tabs down at the bottom here, you'll see. And we're going to get into each of these as we go through the course together. So what this calculator allows you to do is to place data into these boxes here, and then it's going to calculate a bunch of stats over here. So I'm going to go ahead and put Ernie's in. Ernie's test scores, this is the same one we just did on the board. So we got an 80, let's see, 81, 83, 79, and 82. Just make sure that when you enter the data points, you're entering them in the whatever color that is, light green area from E3 down to AA7, it looks like. And make sure that each time you enter one, you press enter after it. Like for example, this last one, when I type 82, it doesn't register in Excel until you get out of that cell. Now it registers. Okay. Now let's just go through some of these boxes and see what each one is showing you based on that data. So I put summary measures here and above columns B and C. The first one up there, B4, says X bar. Okay, and that's, I put little comments on each of these. These little red arrow triangles tell you what is in each box. So this is just the average. I didn't know how to make the X bar symbol in Excel, so I just spelled it out, X bar. Hope that's okay. If I can figure out how to put the symbol in there, I will, and then I'll re-upload the sheet. So it's calculating over here the average, and you can actually see the function right there, equals average of all the numbers that are in this range here. And that's the same average that you calculated when we did this a few days ago. I'm going to skip the next 2 cells for a moment, and we're going to come back to them. Down here in cell C7, you see that n equals 5. That's just the sample size, number of data points. And then the next cell down here, I'm not even sure why I included this anymore, but that's just what the data points add up to. I'm sure I included that for a reason. I can't think of why I did right now. Ignore everything down here for a moment. We'll come back to this in the next set of videos. The median is tucked away down here, the 50th percentile. We'll talk about percentiles and how they're tied to the median in the next set of videos. But that's the same median that you calculated when you did it by hand a few days ago. Okay, now let's go back up into here, because everything I've talked about so far is either just simply counting data, adding data, or finding the average of data. I want to talk now about cell C6. That's the mean absolute deviation, and I gave you a mean absolute deviation. So that, if you look at the command that's used in Excel up here, it's avdev, A-V-E-D-E-V, average deviation. I mentioned in the last video that sometimes it's called absolute deviation, sometimes it's called mean absolute deviation, sometimes it's called mean average. It's got a bunch of different names. So just make sure that you know, if you're talking to somebody about stats, that you're both talking about the same thing. Now, up here, this is an interesting one, and there's some neat mathematics going on that I'm going to deal with in an optional video at the end of this playlist if you're interested. You might notice over here I've got a little checkbox that says sample data, and it's checked. If you uncheck that checkbox and then check it and then uncheck it, you see what's changing. Now, hopefully you're noticing, there are 3 cells that are changing names. I'm going to start with this right now. When I have sample data checked, meaning that these 5 data points here are drawn as a sample from a larger population, cell B4 says X bar, which we talked about this a couple days ago, is the sample average symbol. This sample size down here, or the number of data points, I'm calling little n. That's generally the symbol that's used for a sample size. But this is the tricky one up here. This says S. Now what S is S is the sample standard deviation. When I click this to change it to non-sample data, which is the assumption is it's population data if it's not sample data, you'll notice that the average changes from x bar to mu. We talked about this briefly a couple videos ago. When you're dealing with a population, the average is referred to as the Greek letter mu. But when you're dealing with a sample, the average is referred to as just the symbol x bar. Why? I'm sure there's a good historical reason for it, but that's the distinction between averages. You've got the entire population, which just FYI, you very rarely do. You very rarely have the entire population. You call the population average mu. And often, you'll often see that the population size is referred to as capital N. So I've kind of kept that convention in this spreadsheet. Now, the big one that I want to chat about right now is the standard deviation box. I called it little sigma, and I really wish I could figure out how to put the symbol for little sigma in here. It looks like this. That's the population standard deviation, or the sample standard deviation is referred to as little s. So just recapping here, the symbols that are used in statistics. When you have a population, the average is referred to as mu, and the standard deviation is referred to as little sigma. When you have a sample, the average is referred to as x bar, and the standard deviation is referred to as little s. But the big thing that y'all might be noticing is the measure itself actually changes. For example, 1.41. This is the standard deviation that we got when we calculated Ernie's standard deviation on the board. Well, according to what I've got in this spreadsheet, that means we actually calculated the population standard deviation. And we did. The sample standard deviation's value is a little bit different, especially for small samples, because the formula is a little bit different. Here's the difference in the formulas. The population standard deviation is exactly as we did it on the board. Here it is right here. Notice you add up the squared deviations from mean, and then you divide by how many of those data points you have. The sample standard deviation looks like this. It starts the same way. You add up the squared deviations from the mean, but you divide by one less than the sample size. And that is what I want to tease out in the video at the very end of this playlist. I gotta be careful, because the real reason why that n-1 is used over n is actually something for your Math 244 instructor to really get into, because it has to do with a lot of Math 244 topics. But I think I have a way to explain it. So I'm going to have a video at the very end of this playlist if you want to take that deep dive. Don't worry about it too much. Generally speaking, you're always going to have this sample data checkbox checked, because most of the time you're dealing with a sample drawn from a population. If you want the numbers that we do for Bert to match the numbers that we did for Ernie, you can uncheck that box and say to yourself, okay, these are the only 5 test scores that Bert has, therefore I'm going to call it a population. Hey, that's totally fine. Let's go ahead and put Bert's scores in there now. 68, 82, 94, 61, and 100. We knew that Bert had the same average as Ernie. That was one of the fun things that we kind of discovered. And the reason is his test scores add up to the same amount. We knew his median was 82. We also figured that out a couple days ago. This is the interesting thing. His mean average deviation, which I'm going to have you calculate by hand in the homework, you can actually check your answer here, is 13.2. And I mentioned that it was going to be larger than Ernie's 1.2. And it is. It's much larger, which makes perfect sense because his data is more varied. This is just, like I said, another way of measuring that average distance of the data points from average. The distinction between sample and population right now isn't hugely crucial. I'll try to always be cognizant of what I ask you for, whether I ask you for the sample or for the population standard deviation. Generally, you're going to use the sample standard deviation most. It all depends on context. And we'll get good at talking about this as we go through the course. Okay, so that's how you use the raw data stats tab in the Excel calculator. There's more to it. I'm going to back out here a little tiny bit, zoom out. There's more to it. You can have it draw a histogram down here if you want, and you can have a percentile calculator. We'll talk about the percentile calculator in the next series of videos. The histogram calculator is awesome, but usually not for small data sets. Like, for example, I can make a histogram of this data if you want. It's just not going to be really interesting to look at. Histograms are usually going to be better for larger data sets. We'll start looking at the shape of larger data sets. But I just wanted to get you in here right now so that you could see the first few items of this spreadsheet and how they work.